Today, we're continuing with ratios and proportional reasoning and percents, but we're moving into analyzing circle graphs. For the first part of your assignment, you're going to look at the image of the circle to the right, and I want you to write in the text boxes what you notice about this image and then what you wonder about this image. You'll be hearing a lot about 360 degrees as we work on circles. Did you know that every circle can be divided into 360 even units called degrees? So if you turn around in a full circle, you turn 360 degrees. If you simply turn halfway around a half circle, you turn 180 degrees. So I actually had no idea why circles were divided into 360 degrees. So I found this great website called wonderopolis.org, and they have all kinds of information about any kind of thing you could possibly wonder about. And I learned something new. So I learned that mathematicians believe the ancient Babylonians are to blame for having 360 degrees in a circle instead of something simpler like 100. In about 2400 BC, they noticed the circular motion of the Earth around the sun. They also calculated that it took about 360 days for this circular orbit to be completed. Therefore, they decided to divide the circular path into 360 degrees. That way, they could easily track each day's passage on a circular calendar. So if you get confused in geometry by the number of degrees in a circle, please blame the ancient Babylonians and not Miss LaFave. So what is it that these degrees are measuring? They are measuring the central angles in a circle. A central angle is just an angle whose center point is in the middle of the circle and its end points are on the circle. Or you might think of that as them being on the outside of the circle. Here are a few examples of some central angles and their measurements. Notice there's 3 here with different measurements, but what I am measuring is not the distance between these 2 points, but how open the angle is here. So how do degrees connect to percents? Since we know a full circle is 360 degrees, we can say 100% of a circle is 360 degrees. You're going to use that knowledge to complete the table. So when I'm looking at this table, I know I'm missing a lot of information, but because this side represents the degrees of the central angle, this side represents the percent that that angle is taking up of the circle, then I'm going to go ahead and put in the information that 360 degrees is 100%. And then I can use proportional reasoning to complete the rest of this table. So as you complete the rest of the table, the key thing I want you to figure out here is how many degrees in a circle would equal 1% of that circle. The next part would be some practice problems. You have these practice problems that come from a circle chart or a circle graph called How Much Water Do We Use? So these questions, we'll work on them together, but we won't solve them. You will solve them when you're doing your practice in the actual Google assignment. And then your last bit of practice today comes from an IXL activity on circles and central angles. So before you get started on that, let's go over just setting up these problems. The thing is, I can use percent equations here to calculate either the percent of a section in a circle or to figure out the degree measure of a section in a circle. And the first 2 questions, I've set them up in that kind of, I'm going to call it the simplified form. This was how we were trying to write questions in order to convert them into a percent equation. So the first question says, what is 16.8% of 360 degrees? So here we have a circle graph. I know that all of these sections together, their degree measures would equal 360 degrees. I also know all of their percents added together would equal 100%. So the 16.8 comes from the amount of our water use that comes from the shower. Remember, these words can be translated into symbols, or some of the forms need to be translated into a different form. Whenever we did the doodle notes last week, that's when we talked about this. So when it says, what is 16.8% of 360 degrees? My first thought is, I know that what is an unknown. So I'm going to call what the W. You just pick a variable for the unknown. Is, we know, represents equals. And then I have that 16 and 8/10%. I cannot use the percent form. I need to convert it into its decimal form. To do that, I divide by 100, and 16 and 8/10 divided by 100 gives me 168 thousandths. Of, meaning multiply. I'm going to use parentheses to show my multiplication. The 360 degrees, and this we would just write as 360. So now if I solve this part of this equation, I'm going to know what degree measure 16.8% of the whole circle would be, right? So they've given me the percentage of water that is used by the shower, but what I don't know there would be the measure of the central angle. Now, here is another question set up similarly, but you're going to notice that I have a little bit different information in this one. So here they've actually given me the central angle measure for one of the sections. And that section is for the faucet, how much water use comes from the faucet. It says 56.52 degrees is what percent of 360 degrees. So here, what I'm going to do, if I wanted to use a percent equation here, I'm going to say the 56 and 52/100 degrees. That doesn't need to be changed into a different form because it's degrees, so I don't change it. I'm only changing the percent form into a decimal form. Is, meaning equal. What percent? That is an unknown. I don't know what percent it is, so I'm going to use a variable of 360 degrees. So one way to solve that problem would be to use this percent equation. If you need help with solving this, you need to either reach out to me or a math specialist or review videos and lessons from last week, because we talked about how to solve to get a variable by itself. The third and fourth questions, these now aren't written in the simplest form. So instead of showing you how to write the percent equations for these, I'm going to show you how to write them into this more simplified form. When you're practicing today, you will write the percent equation and solve yourself. Don't forget also to solve the first two and put your answers in the text boxes. So what is the measure of the central angle in the toilet section? So I'm going to find toilet. So the water use from the toilet, it's actually looking like it's the largest section, and it is 26.7%. So what I need to think about here is, how am I going to figure out from that the number of degrees that equals, because the degrees measure the central angle. So the question I'm going to ask myself then is, what is 26.7% of the circle? And I know the whole circle is 360 degrees. So that would be the setup. I would then write my percent equation from that. Question 4. What percent of our water use is from using the clothes washer? So here I know that it's 78 and 12/100 degrees. So the question I have for myself in this would be, what percent of the circle is that? So in other words, I would say, what percent of 360 degrees is 78 and 12/100 degrees? From those, you'll write your percent equations and solve. and then go on to complete the IXL activity. Make sure that you calculate or translate your score onto the Google slide, so I have a copy of your score.